there are some certain points that you should keep in your mind while designing the powder metallurgy part, or basically during that how the part is manufactured with the help of die and punch. So what should be the design of your die and punch so that you will get finished part, and without any difficulty and without any failure during the ejection. So the first point is that the part should have vertical or near vertical sides to permit the ejection from the die. Okay, so that means if you will always try to make the die cavity or the part, you will select the part or the design, and to ensure, you will ensure that it will have most of the vertical sides, and it will help in the ejection from the die. And but however, you can take some steps in the geometry. Steps can be allowed, just like there, this step and this is your step. So but you see here that all the sides are vertical. Okay, and then next point is this, that undercuts, these type of undercuts and these hold from the side walls, from the side, are avoided. Okay, so what will happen, that suppose if you have how you can do it. First of all, it is a very difficult challenge to create the side hole during the pressing. In the you have to, it is a very difficult challenge to make such a die which will produce the side hole. Okay, somehow suppose if you have produced the side hole from any method, and suppose if there's you have some sliding mechanism is there and anything, if you manage to get the side hole, then you think that it will create a problem during the ejection. So this side hole is not allowed. And similarly, this type of undercuts will also be not allowed, because the part has, if the part has consolidated, then it will, for providing such type of undercuts, you would require some features in the internal side of the die, and that will also cause as a barrier during the ejection. So this type of features like side holes and undercuts, undercuts are not allowed. However, this type of vertical undercuts and this type of vertical holes, either the through holes or the blind holes or the stepped holes, they are allowed and permitted, and you can easily fabricate your part or die and without any problem in the ejection, and you will not be able, then you will have a safe part ejection. Okay, then the third point which you should keep in mind, that screw threads cannot be fabricated by powder metallurgy pressing. Similarly, screw threads, those threading features or their grooves will pose a problem during the ejection, so they are not to be fabricated in the powder metallurgy pressing stage. However, if you want some threading on the part, then you can easily machine it after the sintering process. So not in the after the compaction stage, but after the sintering stage. So after sintering stage, you can easily do the machining because the material has acquired its sufficient strength. So these are some important points that you should keep in mind while designing the part and while designing your die. Okay, and the next point is about the wall thickness. So this wall thickness, how minimum wall thickness you can keep in your powder metallurgy part. So the manufacturers or the scientists have basically seen that the minimum, there should be a minimum wall thickness should be of this 1.5 mm between the holes. Suppose if you have a part like this and then you have made two holes, and so the boundary between, you can say, the gap between these two holes should have at least 1.5 mm thickness. Or if suppose if this hole is offset from the center, it has some eccentricity, then also the wall thickness should be more than 1.5 mm. Okay, so this is the minimum recommended hole diameter. which is and okay, and this is the wall thickness, and also the minimum, what should be the minimum size of the hole diameter. So that hole diameter should not be less than 1.5 thickness. Otherwise, if you try to manufacture it, you will not get the required hole. You can say the hole concentricity, and there will be a distortion in the hole during the sintering process. So this is about the wall thickness and the hole diameter. Okay, and try to keep the shape of the compact as simple as possible, and the cross section should be uniform as much as possible. Sharp changes in the corners, thin sections, variation in the thickness, abrupt change in the thickness cross section, and high length to diameter ratio should be avoided. So maximum length to diameter ratio for your powder metallurgy part is permitted is to 8:1. So if you try to make a part very lengthy and having a very small diameter, it will cause the problem in the ejection during the sintering process. After that, you can also observe some buckling in the part during this after the sintering process. So such type of mistakes should not be done while designing the part. So in this case, like this type of feature, suppose if you have a slot or a hole like this, so this sharp radius should not be formed in the die, and rather you can make a fillet radius in the sharp in the corner. Okay, similarly here in the case if suppose if you have a stabbed radius, then also there should not be a sharp radius in your part, and then you can make it into a fillet radius. Suppose if you have a part like this, so again this type of sharp change in the radius, sharp change in the cross section should be avoided, and the corners and these particular undercuts should be filleted, should be given some fillet radius. And this type of sharp radius, pointed radius should not be there on your part geometry, and you should give some fillet radius, and it will all help in during the ejection process, and as you know that this sharp radius, this sharp change, abrupt change in the cross section, they act as a stress ratio. So during, even during the compaction pressure, when the pressure is applied, then also you will find certain cracking at these sharp corners and this sharp these sharp radius, you can say the sharp corners and sharp edges. So such type of problem should such type of error should be avoided. And chamfers, similarly, the chamfers and corner radii are possible by powder metallurgy pressings. Problem are encountered in punch rigidity when the angles are too acute. So suppose if you have a part like this, that you have there is a central hole in between the part, and then you want to give this fillet at the corner, then you see that two sharp angles should not be there. So at least this 45 degree of minimum fillet is or the radii corner is given in the part. Okay, suppose if you want to make this part, if you want to give this much of the acute angle, then there should be a similar type of shade should be all present on the punch. And if you see that that punch will become your sharp, and it will lose its rigidity, its dimensional rigidity. Similarly, this type of radius, these types of radius are recommended, and this type of figure should also not be formed and selected in your part. That you have a very round corner, so it will also lead to the sharpening of the edges of your punch, and it will lose its rigidity, and it will fail in the course of in the longer duration. So this type of radius, small radius, and the fillet of 45 degree is preferred. Okay, and this is the last point, that part must be machined in order to achieve multiple steps, otherwise the tooling will become complex. So suppose if you want to fabricate a part like this which has multiple steps, 1 step, 2, 3, 4. Okay, so for achieving the uniform density, what you will do, you can think about using the multi punches, one big punch from here and then four punches from this side and four punches from this side. So you see that tooling will become complex and it is very difficult to control the motion, the predefined motion of all the punches. Punch travel will be a very difficult task for you. So in such cases, what you will do, you can make a part like this, that it has only two step. This is the one step, and another is the second step. And then you do pressing and then sintering, and after that you can easily machine this part and then can produce the required steps. So such type of strategy you need to decide while designing the parts and the fabrication of the powder metallurgy components. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.